we have another shot to go because we have part B. If you didn't fully understand what was going on here, let's try the same argument for the other infinite series. So let me just copy that down here. It's minus 1 to the n over n factorial. Okay, here we go. Minus 1 to the n, n factorial, right? And then n starts from 0. Okay. By the way, 0 factorial is 1. You're safe. You're not dividing by 0 for n equals 0. Okay. 0 factorial is 1. You're safe. Okay. By definition. Okay, I'm going to isolate the non-alternating part. So that's 1 over n factorial. You can pause the video and go ahead and then use the alternating series test to prove the convergency of this series. I'm not going to do it here because that's not the purpose of this example. You can pause the video and then check the conditions of the alternating series test. Okay, that shouldn't be hard. Okay. So what I'm going to do here is that the sum, the actual sum is s, and I'm going to approximate it by the partial sum so that s minus sn is the tail that I discard in the infinite sum. So that means I'm making an error. And that is the absolute value of the tail. Okay, as I just said. And the alternating series remainder theorem says that this absolute value of Rn is less than an plus 1. There we go. This is less than or equal to 1 over n plus 1 factorial. Okay. I use capital N to make it more clear because if I use little n, you may be confused. Let's say like capital N is the number of terms I keep in the partial sum. Okay, so the very immediate term after I cut off is a n plus 1, capital N plus 1, right? So that's this term. Okay. And I want this number to be strictly less than 1 over 1,000. Again, this is a trial error business, right? So I'm gonna choose certain n values to come up with the smallest possible n. Okay. So when n equals 1, this is 1 over 2 factorial, right? 1 over 2 factorial is 1/2. 1/2 is not less than 1,000. So n equals 1, n equals 1 is not good. How about n equals 2? When n equals 2, it's 1 over 3 factorial, right? 1 over 3 factorial is what? 1 over 3 times 2 times 1, which is 1 over 6. That's still not correct, right? How about n equals 4? N equals 4, then this is 5 factorial, right? 5 factorial is 5 times, 4 times, 3 times, 2 times 1. That's 120. Still, we couldn't make it to thousands, right? 6 factorial is 1 over 120 times 6, which is 720. If you have your calculator, by the way, have it ready with you so you can actually calculate those faster than me. Okay, so if n equals 5, this is 1 over 6 factorial, and that's 1 over 720. We still couldn't make it to 1,000, but 7 factorial will make it because I'm going to multiply this number by 7. So there you go. So I'm going to take n to be 6, so that 1 over n plus 1 factorial is 1 over 7 factorial, and that is 1 over 5,040. That is definitely less than 1 over 1,000. Okay, so what I'm going to do is keeping only 6 terms in the sum is good enough out of infinite to many sum, by the way. You just keep the first 6 terms in the sum so that you can make an error less than 0.001. That's a very strong result. Okay. And here is the graphical outlook of that. So this is n equals 1, n equals 2, as you see, n equals 3, 4. Look at the error. This is still bigger than 0.001. And n equals 5 is the same. And if you go to n equals 6, then the tail, the absolute value of the tail, is less than 0.001. Let me see if that's going to come out here in the animation, but I think there should be like n equals 6 here somewhere. Okay, there should have been 6 here. Okay, but it doesn't come out here. So, but make sure that if you do this by yourself, you will see that n equals 6 is going to give you this number less than, not this number obviously, something less than 0.001. Okay. I hope this graph explains. See, like the sum, in fact, converges to actual sum, and the difference between the actual value, this is a dashed line, and the approximated value is going to be less than 0.001. All right, we use the alternating series remainder theorem to approximate infinite series and to decide how many terms in the sum we should keep to get an error less than a prescribed value. I hope I made it clear, because this is one of the hardest topics to explain to students. So I hope I did my best to explain it. So if you have any questions or comments, please forward those my way. And this makes it the end of the video. Thanks for watching. I'll see you in another video. Bye.